Hey, what's up, everybody? Hope everyone was able to have a good spring break. Um, and as we come back from the break, we're going to finish chapter 6. So I know we took a test. This will be the last unit. Probably have a quiz on it instead of a test. But 9.6, we're going to talk about solving right triangles. And we'll talk about what that means in just a sec. But before we get to that, let's talk about finding angles. So, in the last couple sections, we found a lot of different ways of finding side lengths. Okay, so if you guys remember that we had examples on our test and throughout the unit where, given an angle A and some of these other angles, we could find missing side lengths of a right triangle. So, for instance, if we had this one as 3 and this is x, well, we could do tangent of angle A, we'll just say is, I don't know, 20. So if tangent of 20 is equal to 3, okay, or tangent of 20, we know that the tangent is equal to, I'm going to call this x instead. But if we did tangent of angle 20, this would be equal to 3 over x, and we could solve for that missing side length. So this is what we did. We found missing parts, missing side lengths of a triangle. But now we're going to use these trigonomic ratios to find angles, not side lengths, angles. So here's how you could use trigonomic ratios. We use what we call inverse trigonomic ratios, or in this case, you might hear them referred to as arctangents. So let's say we have inverse tangent. We'll call it inverse tangent. Now I'm going to also just right above it say arctangent or inverse tangent. You can hear this interchangeably as kind of the same thing. I like to use arctangent in this case, though, so I like to refer to it as arctangent. Because there is an inverse tangent ratio, so I don't like to get them confused. So, in any case, so arctangent, inverse tangent, okay? So, arctangent, inverse tangent says that if tangent of A is equal to, so this is saying this angle right here. If tangent of angle A, now we know tangent is equal to, we know that tangent is equal to opposite over adjacent side. Now let's just say that this is equal to x. We're just going to call it x. So if tangent of A is equal to x, then arctangent, which we write as this. This is how you write your arc or inverse tangent. With a tan, and then you kind of have it with a power of -1. But this is what we call as inverse or arctangent. So tangent inverse of x then would be equal to A. So you see here that we have tangent of A is equal to x. Well, if I want to solve for whatever this is right here, whatever angle this is, then I can use the tangent inverse to get rid of this, and then I take the tangent inverse of both sides, like right here, and that's how I can find A. And then you can say the same thing for arc sine. If sine of A is equal to, we'll just say y, then sine inverse of y is equal to A. For arc cosine, if cosine of A is equal to, we'll say z, then arc cosine or cosine inverse of z is equal to A. So let's see how we could apply this to find missing angles. Okay. But before we do that, let's make sure that we know how to use No, yeah, let's do it here. So here we have tangent of A is equal to 0.75. Okay, 0.75. Now we want to solve for A. Want to solve for A. So in order to solve for A here, now this is an equation and we have two sides. Here's 1 and 2, two sides of an equation. And to get A by itself, I'm going to use tangent inverse. Okay, so I'm going to do tangent inverse of tangent of A equal to tangent inverse of 0.75. Now on the left side, because this is tangent inverse and tangent, those will cancel, so I'm just going to be left with A. So I have A is equal to tangent inverse of 0.75. And now I can use a calculator and punch in tangent inverse of 0.75. So here's my calculator here. Now you have your tangent, your sine, cosine, and tangent buttons, and then if you're using the right calculator, if you do second, and in this case I'm going to press on the tangent button, you can see that in blue letters on the tangent button there's in the top left of the corner of that button is tangent inverse. So that's how you use your tangent inverse. And do 0.75, do enter, and there you go. Now I found the measure of angle A. I'm going to call measure of angle A 36.9. So A is equal to 36.9 degrees, because it would be degrees. Okay, let's go on to the next one. So I have sine of angle B is equal to 0.87. Now B is an angle and I want to find that angle, so in order to get rid of the sine over here I need to do a sine inverse. So sine inverse of sine of B is equal to, now because I did sine inverse on the left side I need to do a sine inverse on the right side. So sine inverse of 0.87. Now on the left side the sines would cancel and I get B is equal to sine inverse of 0.87. And if you put that into the calculator, you should get about 60.5. Again, we are talking about angles, so in degrees. And then cosine of C, I need to get C by itself, so I'm going to do cosine inverse of cosine of C is equal to, now I have to use the cosine inverse on the left side of 0.15. Those will cancel, so I'll be left with C is equal to cosine inverse of 0.15. And if you put that into your calculator, you should get 81.4 degrees. Okay, now I want you guys to try it on these ones right here. Solve for angle H in all of these. So you have to use the correct inverse ratio. Okay, so now that we know how to find both side lengths and angle measures, we can talk about solving a right triangle. Now to solve a right triangle, this means, to solve a right triangle means to find all side lengths and angles. So to find all side lengths and all angles of a triangle. Okay, now you can do this, so you can solve for a right triangle if you know one, if you have two side lengths, or two, if you know one side length and the measure of one acute angle. Okay, so essentially if you're going to solve for a right triangle, you need to have some information already given to you. So that's either going to be 2 side lengths or 1 side length and a measure of an acute angle. So in this example right here, you can see that we have 2 side lengths here, and we're missing the third. So let's solve for the right triangle. Now, that means I need to solve for side length C. I'm missing side length C, and I'm missing angle B and angle A. These are the 3 parts of this triangle that I'm missing. So in order to find this side length, well, we already know the Pythagorean theorem, so we can solve for that. So I can take 3 squared plus 2 squared equal to C squared and solve for C. So this would be 9 plus 4 is equal to C squared, which is 13 equal to C squared. Take the square root of both sides, so I know C would be equal to the square root of 13, which is approximately 3.6. So we'll just round this off to 3.6. Approximately. Okay, so now we have to find measure of angle B or A. And I don't think it really matters. Okay? The only thing that matters is how you set it up. So what I could do is notice that I have this side length and this side length right here. Now, relative to angle B, this would be the opposite and the adjacent side. So that means I could use the tangent of B, which would give me the ratio of 2 divided by 3. Now, by doing this, I only have one missing variable, which is the B variable, which is my angle. So now I can solve for this because I know how to use tangent inverse. I know how to use my inverse trigonomic ratios. So I'm going to do the tangent inverse of both sides. So tangent inverse of both sides, which means these would cancel, so B would be equal to the tangent inverse of 2 divided by 3. So if we come here, we do tangent inverse of 2 divided by 3, I get 33.7. I can round up right there. So I'll say that angle B is equal to about 33.7 degrees. So this angle is about 33.7 degrees. Now I need to find angle A, and again I can use my tangent ratio, which would give me 3 over 2. So I know tangent of A, I'll do this over here, so tangent of angle A would be equal to 3 divided by 2, and I can do a tangent inverse of both sides to get the A by itself. So those would cancel, so A would be equal to tangent inverse of 3 divided by 2, which will equal about, that should equal about 56.3. Now, there's another way we could verify this. What we could do instead is, because I know that this angle is 90 and this angle right here is 33.7, I could just subtract those from 180. So I can do 180, subtract 33.7, subtract 90, because it's a right triangle, and there you go, you get 56.3 degrees. Okay, there you go. So now we know all the side lengths and we know all the angles. Thus, we solve for the right triangle. Okay, let's go over here to example 4. And now in this case, so in the case before we were given 2 side lengths, which was one of the situations that we could solve this. In this one, we're going to have 1 side length, which is right here, and one of the measures of the acute angles. Okay. Now, in this case, we want to start, it would be easy to start by solving for this angle right here, because we already know these 2 angles, and we know the sum of the triangles is 180. So I can do 180 subtract 90 subtract 25. Whoops. So 180 subtract 90 subtract 25. And I get 88. No, I get yeah, 88. I think I did something wrong. Oh, because I subtracted 2, not 25. So 180 subtract 90 subtract 25. There we go, 65 degrees. So angle G, so measure of angle G is equal to 65 degrees. Okay. And now that I know that, I can solve for, well, I honestly didn't need to know that for sure, because now that I have these, this is all I really need to solve for these right here. I don't really need the other angle, but it does help. It can help. So notice that I have this angle, and relative to this angle, I have the hypotenuse and the adjacent side relative to h. So again, that's the hypotenuse and the adjacent side, which is which can help me set up a cosine ratio. So if I do cosine of 25, that is equal to that's adjacent, which would be side length g divided by 13. Excuse me. Now this is stuff that we covered in the previous couple sections. So I'm just going to solve for g by multiplying by 13. So I know that g is equal to 13 times cosine of 25. Again, I'm pretty sure you guys are pretty familiar with this. So just to give you what the answer should be, but if you are following along with your own calculator, you should be able to get this. But well, I guess I can go ahead and show it. We have time, so I can do 13 cosine of 25, and I get 11.8. So that is the side length here. And then I can solve for h. Now relative to angle h, that would be the opposite over the hypotenuse. So then I could use sine of 25, which would be equal to h over 13. Solve for h, so I can multiply by 13. So h is equal to 13 sine of 25. So 13 times sine of 25, and I get about 5.5. So h is equal to about 5.5. Okay. So there you go. I found all 3 missing parts, and that's what I need to solve the triangle. So I want you guys to go ahead and try and do these techniques from examples 3 and 4 with these examples here. Just notice here that I have 2 side lengths. Here I have an angle and a side length. Okay. Alright, now that should pretty much wrap it up for 9.6.